This is a video tutorial for tutorial 4 question 2. So in this question we're given two functions, f that maps x onto negative x squared plus 2x plus 1, where x is less than some constant a, and we're given the function g that maps x onto ln of negative x, and this only works for x's between negative 1 and 0. So what do we have to do? The first thing we need to do is write down the largest value of a such that the inverse function f inverse of x exists, and define f inverse in a similar form. So f inverse exists if and only if f is 1 to 1. Right? Now how can we tell if f is a 1-to-1 function? We need to draw the graph and do something called the horizontal line test. So let's look at the graph first. This is the graph of y equals to f of negative x squared plus 2x plus 1. Now we can see quite clearly that this is not a 1-1 function, because almost any horizontal line will cut this graph twice. So we need to put a restriction on this so that it can only go up so far, and then we cut away the second half because it's x less than a. So what value of a are we going to choose? We need to find out what this maximum point here is. That isn't too difficult to find out. That maximum point is 1, 2. So I can put that in. Oops. I can put that in here. That is the maximum point. So we need x to be less than 1 for this to work. So from the graph, so the graph looks something like this. That's the point 1, 2, y equals to f of x. Okay, so that's so f is 1 to 1 if a equals to 1. So now we need to find the inverse in similar form. So to find the inverse, we start with the equation y equals to f of x, which is y equals to negative x squared plus 2x plus 1. We try to make x the subject of this equation. To do that, what am I going to do? I'm going to complete the square. I don't like completing the square with a negative in front of my x squared, so I'm going to move that minus sign over. So negative y is equal to x minus 1 squared. This includes a plus 1, so I need to minus 1 away from it, and then I get a minus 1. So 2 minus y is equal to x minus 1 squared. Let's just move down a bit. So x minus 1 squared is equal to positive negative square root of 2 minus y. Sorry, no squared there. X is equal to 1 plus or minus square root 2 minus y. Now, which one would we use? Well, if you look at the values of x we need x to be less than 1. So we're going to reject positive in this particular case because I want my x values to be less than 1. So my final answer would be x equals to 1 minus square root of 2 minus y. But we're asked to express it in similar form. So how do we do that? It'd be f inverse maps x onto, we take this expression and swap our x's and y's again. 1 minus the square root of 2 minus x. Give its domain. We can see here we'd need the y's to be less than 2. So that becomes the domain of f inverse. X is less than 2, and that is our answer to part 1. So let's look at part 2. Using the value of a found in part 1, show that the composite function f inverse g exists. Define f inverse g in similar form. Find its range exactly. So similar thing, right? Part 2. f inverse g exists if and only if what condition is met. This exists if and only if whatever g can produce can be interpreted by f inverse. So what is it that g can produce? Well, let's take a look at this. G is the graph of ln of negative x. So if I were to sketch it, it would look something like this. But that's not entirely true. The intersection point would be -1, this is 0. That's not entirely true that this is all g, right? Why? Because g is restricted to just being between -1 and 0. So this portion of the graph here would not be included. And in fact, neither would -1 or 0 because of the strict inequalities. So what g can produce is just these numbers here, which means that the range of g is actually equal to -infinity, because I can go down as far as I like, but I can never quite reach 0. Fortunately, however, that is a subset of the domain of f, which, if you recall, was numbers smaller than 2, so -infinity up to 2. So therefore, range of g is a subset of domain f inverse, therefore f inverse g exists. So now that we know that it exists, we need to be able to express it in similar form. How do we do this? Well, we work out what is f inverse on g on x to find the rule. This means I want to know what is 1 minus, actually no, let's not do it that way. I want to find out what is f of ln of minus x. So f inverse of ln of minus x. So f inverse is 1 minus the square root of 2 minus whatever our argument is. In this case, that's ln of minus x. So this can't actually be simplified, so we stop here. This is the rule, and the input, of course, has to be the domain of g, which is 0 to 1. So to define f inverse g in similar form, what do we get? F inverse g maps x onto 1 minus the square root 2 minus ln negative x, where -1 is less than x is less than 0. So what numbers does this produce? Well, again, two ways of doing this. We could try putting the range of g into f inverse and see what we get. Easier way, however, may be just to use our calculator. So let's bring that up. So this is what this graph will look like, our graph of f inverse g. And it's got a pretty interesting shape, as you can tell. But I only want to consider numbers between x equals to -1 and x equals to 0, which is of course the axis. So what I'm going to do is I'm going to find these 2 points of intersection. I can see comfortably that this goes down all the way to -infinity, so I'm not going to worry about that too much. And I'm going to turn my rounding into 3 significant figures so I can see this a bit better. So you can see here, when x is -1, our value is -0.414. Right, so I can therefore say, I can go all the way, the range that's produced is all the way down to -infinity, but up to -0.414. Well, actually, I realize I can't do this. Why not? I mean, it's the right answer, that's true, but if I reread the question, I need to find its range exactly. How could I find this value exactly? Well, I know where it happens. It happens when b equals to -1. So let's see what happens if I put -1 into this equation. So if I were to put in -1, f inverse g of -1 would be 1 minus the square root of 2 minus ln -1. That's ln of 1. So this is just 1 minus root 2. And so that is the y coordinate that we're seeing here. This is the value, negative 0.414 is 1 minus square root 2. So now that we know what it is exactly, with the help of both our graphing calculator and our function that we've just found, we can comfortably say that the range of f inverse g is equal to, we saw that it went all the way down to negative infinity, it went up to negative 0.414, which is the value 1 minus square root 2. So that is the final answer, and that concludes this question.